NCERT exercise solution for chemical kinetics, and today we'll be doing 4.6, 4.7, 8, 9 and 10. In 4.6, they have given that reaction is second order with respect to a reactant. A reactant means single reactant. Second order means that reactant has got power. Concentration term has got power 2. So we will write down first the rate law expression or the rate of the reaction, and it is given as rate is equal to rate constant single reactant R raised to the power 2 because it is second order. It can be written as Ka square if concentration of reactant is taken as A. Okay, now we will look into the two conditions they have given and what they are asking. How is the rate of the reaction affected if concentration of reactant is doubled and reduced to half? So two conditions are there. They are changing the concentration of reactant and then they are asking you that how rate will change. For the first one, first is your concentration of reactant is double. That is, initially it was A, so now it is 2A. So this is the first condition given. And we will be calculating rate. So the rate will be affected and new rate will be rate constant. And we will put down the value of R, which is 2A raised to the power 2. Okay, we will use this expression for giving the rate. So this is the value. Now we will open the brackets and this is equal to K dot 4, 2 to the 4 A square, or we can write it as 4 dot Ka square. Now this part is the original rate. Have a look here. Ka square is the original rate. So what does it mean? When we double the concentration of reactant, rate becomes 4 times. This is the first answer. Okay, now come to the second part. In the second part, they are saying that the concentration of reactant has been made half of the original value. So we'll write it as A by 2 and we'll calculate new rate. New rate is given as rate constant. We'll put down the value in place of concentration of reactant and we'll put power 2 according to the rate expression. So we'll open the brackets and we'll get K dot A square 4. Okay, we can simplify this as 1 by 4 dot Ka square. Again, this value is the same. This one. So what does it mean? Rate become 1/4 of the original value if we make concentration of reactant half of the original amount. So this is your second answer, or the answer for the second part. Now come to the next question. In the next question, what they're saying, what is the effect of temperature on the rate constant of a reaction? We have to give the effect of the temperature. So if generally we are finding what is the effect in general term, so we have to remember always that the rate constant increases with increase in temperature. Rate constant increases with increase in temperature. And the how specifically we will write it that for every 10 degree rise in temperature, your rate constant K will get doubled. Okay. Now next part of the question. In the second part, they are saying that how can this effect of temperature on rate constant be represented quantitatively? Okay, we have to give this idea quantitatively also. So quantitatively. Quantitatively means we should be able to give some calculation and exact value how the rate constant value changes with temperature. So it is given with the help of Arrhenius equation. Okay, Arrhenius equation. Now, what is Arrhenius equation? It is given as rate constant of any reaction is equal to capital A E raised to the power EA divided by RT. Now, what is this equation and what are the terminology? We will see now. So this is called Arrhenius equation. From this equation, we can show the relationship between temperature and rate constant. What is R here? R, all of you know it is gas constant. Okay, it is gas constant. What is T? T is the temperature. And what is EA? It is energy of activation for the reaction. It is energy of activation of a given reaction. And A is, this is new term. What is A? A is called as Arrhenius factor or frequency factor, or we call it as pre-exponential factor. Okay. Either of these, either Arrhenius factor or frequency factor or pre-exponential factor. And one thing which is important to remember here, that A is constant for a specific reaction. Okay, its value is constant for a given reaction, but if we change the nature of reaction or we find out value of A for different reaction, the value will be different. It will not remain same. So this is all about how temperature and rate constant are related. Now come to the next question, 4.8. In this question, they have given a pseudo first order reaction. Pseudo first order reaction means reaction which appear to be first order, but exactly it is second order. And why it is second order? Because the concentration of water is in excess, so it is taken as constant. Therefore, we consider it as first order. Otherwise, it is second order reaction. Now, in this reaction, they are asking you to calculate the average rate of the reaction between time interval 30 to 60 seconds. Okay, they are asking for 30 to 60 seconds. So these are the value for 30 and 60 seconds. We need these value to calculate. Now, average rate of any reaction can be given as decrease in concentration of reactant divided by the time interval for that particular decrease. It can be written as minus final concentration minus initial concentration divided by final time minus the initial value of the time, and we can simplify it as R1 minus R2 divided by T2 minus T1. Okay, now we will put down the values from the table. So in our case, R1 is, what is R1? R1 initial concentration of the ester, we are doing this. So this is the value 0.31 and final is 0.17. So we will write down 0.31 minus 0.17 divided by 60 minus 30, because we are finding between 30 to 60 seconds, and this is equal to 0.14 divided by 30. So we are getting here answer as 4.67 into 10 raised to the power minus 10 raised to power minus 3. And unit will be moles per liter per second, because concentration is given in moles per liter and time in second. So this is the answer for the average rate that they are asking. Now come to the next question, 4.9. Now in 4.9 they are saying a reaction is first order in A and second order in B. Write the differential rate equation. Okay, so for writing the differential rate equation, we have to keep in mind few things. Okay, first we will consider this idea that it is first order in A and second order in B. So therefore a differential rate equation will be small decrease in concentration of reactant divided by small time interval. This is equal to K, and the first idea, that is concentration of A raised to the power 1 and concentration of B raised to the power 2. Okay, this is from the information given. Now second part. So this is your differential rate equation and this is the answer for first part. Fine. Now in the second part they are saying how is the rate affected by increasing the concentration of B 3 times. Okay, so here first we will, for simplicity, we will suppose concentration of A is written as small a and concentration of B is written as small b initially. Okay, now the condition that they are suggesting as how is rate affected by increasing the concentration of B 3 times. So with these values we will write the first rate, the initial rate, and that initial rate naught is given as K concentration of we will write A B raised to the power 2. This is the initial rate. Now if concentration of B is 3 times, that is it is equal to 3B. So the new rate will be rate 1 will be given as rate constant A, we are not changing, so dot A, into concentration of B is given as 3B, so we are writing it like this, and we will be getting K dot A dot 9B square. We can write it as after simplification 9 dot KAB square. This is your new rate. Okay, if we compare this new rate with the original one, that is the initial rate is what, KAB square. Here what we are writing 9 dot KAB square. What does it mean? It means rate will become 9 times. Rate will be 9 times if we are making concentration of B as 3 times. Rate will become 9 times. So this is your answer. This is your answer. Now next part of the question, what they are saying, how is the rate affected when concentration of both A and B are doubled? Here they are changing the concentration of both of the component or both the reactants. So third part, here they are changing concentration of A, they are making it double, that is 2A, and concentration of B as 2B. Okay, now we will put down the values. So the new rate 2 is given as K 2A dot 2B raised to the power 2. We will open it as, it will be K dot 2A dot B square. Okay, we can write it as 8 dot KAB square. So the rate 2 is equal to 8 dot KAB square. And now what we have, this idea, this is the initial rate. So therefore your rate will become 8 times. Rate will become 8 times if we are doubling the concentration of A and B. Okay, so this is third answer. Your first answer was this one. Now come to the next question, 4.10. In this question, they are saying that in a reaction between A and B, the initial rate of the reaction R naught was measured for different initial concentration of A and B given below. What is the order of reaction with respect to A and B? We have to find out order with respect to A and B. This is to be calculated. So for calculating this, first we will have a general equation as a rate law equation. That initial rate of the reaction can be written as K concentration of A raised to the power alpha and concentration of B raised to the power beta. Now what are alpha and beta? So we suppose here, order with respect to A is alpha and order with respect to B is beta. Okay, so by supposing this, we are writing down this rate expression or the rate law expression. Okay, now we have to find out the value of alpha and beta. Now first have a look in the table given here. They have given the different observation and they have calculated the rate at different concentration of A and B. So the first observation is this one, second observation is this one, and the third set of observation is this one. Okay, now have a look here how to find out alpha and beta. In your reaction number, the observation number 1, okay, in observation number 1, concentration of A is 0.2 and here also concentration of A is 0.2 moles per liter. Concentration of A is not changing here. Okay, so from observation number 1 and observation number 2, we can find out the value of beta because concentration of A is not changing. Fine, so we will do like this. First we'll write down the rate, initial rate in case of first observation. This is equal to, for the first observation, it is 0.k dot, k is the rate constant, and it is 0.20 alpha multiplied by 0.30 beta. This is for first observation. Now for the observation number 2. Okay, so for observation number 2, R naught 2, it is given as K dot concentration of the A, which is 0.20 alpha, and concentration of B, which is 0.10 beta. Okay, now what we will do, we will divide rate for the first observation with the rate for the second observation. That is, we will do R naught 1 divided by R naught 2. Now the value of rates you can find out. For the R naught 1, the value of rate is 5.07 into 10 raised to the power minus 5 divided by here also 5.07 into 10 raised to the power minus 5. Now have a look here for the values which are same. K will cancel out. These values are same. This value is also same. So we can put here 1. So what we are getting in the next step, we are getting here your 0.30 divided by 0.10 whole raised to the power beta is equal to what we are left with here, the value 1. Okay, or 3 raised to the power beta is equal to 1. Now here what we are saying, any quantity which is having some power, and if it is equated to 1, that means that power will be what? It will be, beta will be 0. Okay, so therefore the value of beta is 0. That is, in terms of B, the order of reaction is 0. Now have a look here in the table again. For observation number 3 and 2. Okay, observation number 3, have a look here. In observation number 3, the concentration of A is 0.40 and concentration of B is this one. So we will find out the value of alpha from the observation number your 2nd and 3rd. And how we will do that? What we will do, first we will write down observation rate in case of 3rd observation, which is equal to, in case of 3rd observation, it will be equal to 0.40 raised to the power alpha dot, sorry, rate constant we have to write, and 0.05 raised to the power beta. Okay, now rate in case of 2nd observation we have already written, so we divide it by rate 2. So we will write down here the values, and the values are k dot 0.20 raised to the power alpha multiplied by 0.10 raised to the power beta. Now the value of rate we will also equate. So for rate 3, like here, rate 3, it is 1.43. So it is 1.43 into 10 raised to the power minus 4 divided by 5.07 into 10 raised to the power minus 5. It is given here. Now we will simplify this. K will cancel out. Okay, and we will simplify the rest of the things. So in this case, this part will be twice. Okay, and we will write it as, now for beta, for this part, beta is 0. So these two values will be 1. Okay, so we will write it as what we are left with, 2 raised to the power alpha. Okay, and we are getting solution after solving this value as 2.820. Now we will take log of this equation. So log of 2.820 is equal to alpha log of 2, or log of this value is 0.450 is equal to alpha multiplied by log value is 0.301. Okay, these are the log values you can see from the log table. So alpha is equal to 0.450 divided by 0.301. Alpha is 1.5. Okay, so this is your answer. So we are having two parts in this answer. Order in terms of A is 0 and order in terms of, sorry, B is 0 and in terms of A is 1.5. We have to find out order of the reaction with respect to A and B. So answer is order with respect to A is 1.5 and order with respect to B is 0. So this is all for today.